Hi everyone. Now we are going to discuss about the last module, design of the footing for the course of design of reinforced concrete structural elements. As of now, we are discussed about various modules, basic fundamental concepts of the methods for a reinforced concrete structural elements. So various type of the methods, advantages and disadvantages, various design of singly reinforcement and doubly reinforcement beam using the working stress method and the limit stress method we discussed in the unit module 1. Under flanged beam, shear and torsion, they discussed about the module 2 and different type of the slabs and the staircases and how to design the design of dog-legged staircases. We are discussed about the module 3. Then module 4, what is a column and what is the types of column normally we are using, and how to design the axial loaded column and biaxial loaded column and uniaxial loaded column. That everything we discussed briefly in the module 4. Now we are going to discuss about the module 5, design of the footings. So module 5, a limited design, the footing. Here we are going to discuss about the design of the wall footing. What is the purpose of wall footing? How to design the wall footing? And design of axially loaded and eccentrically loaded the rectangle pad, that is the footing. And the same for axial loaded and eccentric loaded for the slope footing. Then design of combined rectangle footing. We are not discussing about the more than two columns, only for two columns only we are going to design. Here, what is the fundamental contents of the footing? Then, how to design the those type of the footing using the limit state method. Now we are going to discuss on the elaborately. Okay. What is the course objective for the module 5? You learn it to understand the various type of the footing. Here we can able to see the different type of the footing is available. As we are isolated footing or combined footing, strapped footing and raft footing. So each and every footing, the application is different. We cannot able to use it for a single application, not able to use for the all the those type of the footing. So each and every footing is having a specific criteria will be there. Okay, so that is based on the land, based on the soil condition and structure. We can able to choose the different type of the footing. Then learners to be design the wall footing. Then what is need by wall footing? So it be a load bearing walls. Okay, it will take for load bearing stability as well as the safety. As per code, how to design the wall footing. Then we are going to discuss about this unit. Then learners to know about the axle loaded pad footing. So load column will be axially. That means CG, then eccentricity be equal to 0. So for here, the uniform pressure on the soil also we need to calculate. And finally, we need to check in the load bearing capacity and the settlement of the footing also. Then learners, you can able to understand the analysis of the eccentric and for a slope footing where we need to use those type of the footing. Then finally, as a learner, we need to understand the design and the combined for the two columns based on the IS 456 2001. So overall objective of the this module is need to design it be a strong foundation to be safe of the structure. Proper design ensure the stability and the safety of the structure and follow the IS code book for the reliable and economical design. So good design today, strong structure will tomorrow because foundation is a base for a soil need to capable for more load loading capacity. So foundation should be a strong. So we need to take care of the foundation when you're going to design and implementation for the construction site. So what is in the footing? The footing is a lower structural the element. So load will be transferred from the column or wall or will be a side. So already last module we discussed about the load distribution for methodology where the load is coming, then how to be loads will be going to transfer to the soil. Everything is clearly we have discussed. So footing is to spread the loads to so soil can be safely carry it. So that will be supporting system we are going to provide the footing. Whatever load is coming from the column, that load not directly into the soil because if you keep the loads directly with soil, settlement will be happen that immediate settlement. will happen. So that's what we need to, we are going to provide the structure, the whatever load is coming, the column going to give the transfer load to the footing, then footing only going to spread into the soil, then only structure will be a safe. Now we see the imagine the load from the column or wall, whatever maybe, how the load is coming from. So again, it will be a load transfer mechanism from the roof slab, then beam, and via column. The total load lighting on the column, or in case of the wall, that is also will be there. Okay, so that wall is coming to the footing. This footing only going to receive transfer to the soil. Then soil receive and support to the load to make the structure to be safe. Then why the footing is be required? The soil has to be limited bearing capacity. Okay. Having a bearing capacity is very low at the soil. So in area, we having a different type of the soil will be there. Each and every type of the soil, the SBC, safe bearing capacity of the soil also will be there. So whatever maybe, if not providing the proper footing, if a load is acting on the structure, then it will transfer to the soil, means definitely the settlement, the structure may be causes to be failure immediately or in the near to the future. So the footing is be a very essential required to take care of the all the load, and also be to save the structure, I mean, and maintain the durability of the structure. So soil can support up to the certain earth pressure. Okay, the footing increasing the area, reducing the pressure to save to the level. Okay, that's why we are providing for the footing. If load is directly to applied, so what will be happen? The soil, say immediately soil will be a fail, the settlement will be occur. The concentrated load causes the excessive of the settlement, or even the failure of the soil will be happen. So already discussed about the basic load transfer, how the load is transferred from the top to the bottom. So initially load will be carrying from the roof, and if you're having a floor, that is also will taking care. Then beam, then the column, having first floor, second floor, third floor, like that. All the load column, then it will be transferred to the bottom of the column. The column or wall loads will be carried. That that total load will be going to the spread to the for footing. The footing is a load area or the large area. So the spreading going to give the soil to transfer the soil. The soil support and resist the load will be a safety. Then above the footing, the structure will be a safe. So column or for footing soil, load is transferred safely. That's why the footing is here essential for the any building. Okay. Now we going to discuss about the various types of the footing. So commonly we are using for the first type is the wall footing. That is a load bearing wall. So it is mainly used for continuous footing under the wall. So like that, in a traditional method, before coming to load bearing structure like a beam, column, or a element, we are used for the wall footing only. So entire wall going to stand on the continuous footing. And second one is isolated. We can call it as a pad, is a footing. Suppose a single column. Where having a single column, we can make for the isolated. That is a pad cutting. And then combined footing. Two types of the combined footing will be there. One is a rectangle combined footing, and is a trapezoidal combined footing. Then both the column load will be the same. We can able to use for the rectangular combined footing. One column load is high, one other column load is very low. There we don't want to use for rectangular column. Then we can go to for the trapezoidal column for economical purposes. So combined footing where you safe bearing capacity soil is very less. Then two column is be very near. We cannot able to give construct for the individual isolated footing. Then we can go for without hesitation, we for combined footing. Suppose the two column when close together or nearly property aligned, then we can go for the combined footing. So next one is for the design of the wall footing. Where are you using for wall footing? Load bearing walls wherever coming there we can able to use for wall bearing. The behavior of the wall footing is the wall is load is be uniformly distributed to the soil. Then this wall footing is the spread load to the soil. So pressure distribution is a uniform. The load will be a center. If the load is applied to this footing, it will pressure distribution will be a uniform. If the load is not center as we having a eccentricity, then distributions will will be ununiform. While designing of the wall footing, the width of footing may be a difference upon the loading condition and SBC, safe bearing capacity of the soil. So when you're designing for your footing, we need to consider the critical section. So bending at the face of the column, having a more bending at the near the support, having a shear also will be occur. So based on that only, we need to provide the bending reinforcement as well as the shear reinforcement. So shear is reinforcement to provide the bottom as that unity where the tension is happening, then we need to apply the forces. For you see the images, the wall footing is with that underground. We are going to dig and we need to provide the footing. Okay, above the footing, wall footing only, the wall load will be there. Okay, all the wall load be transferred to the footing. Again, the footing is going to transfer to the soil. Then above, from upward pressure, uniform soil pressure also will be there when the load is will be uniform in be there. Then reinforcement is to provide the where the tension rain occur, there we need to provide the tension reinforcement. Here the pressure distribution shows the two images. One is if a load is acting on is central. Another one is a load is acting on the eccentrical. If the loading acting on the is be central, the pressure should be a uniform, okay, below the soil condition. If the loading acting on the eccentricity, the pressure should be varies. Okay, where you're having eccentricity, there you're having a more pressure, then other side you're having a less pressure. This is the pressure distribution diagram for the footing. How is the behavior under a pressure for the wall footing? So already discussed the wall load is uniformly distributed over the length of the footing. Footing spreading into the will be a soil. Okay. If you see the critical section, if you take the critical section bending at the face of the wall, shear will be near the support. There we need to check out and need to provide the reinforcement also. For the main bar, is along the length we need to provide, and distribution bar we can need to provide for the perpendicular for the reinforcement details for the wall footing. So some of the table we include that based on the expert, what is the wall footing and the behavior and what is the key point of the wall footing. So where we can able to use this type of the footing and load bearing walls wherever having, then we can able to use for this wall footing. Okay, so it provides a continuous support and continuous footing under the wall. What is the behavior? Is a uniform load pressure. So automatically the spread to the load to soil. So works like a strip slab. It's a concrete strip beam or strip slab. It will behave. So pressure distribution. If the load is acting on the center, the pressure distribution is a uniform. And the behavior it be a safe style structure and avoid the high pressure will be a soil. So where having a critical section, bending phase is at a phase and shear be near support. So reinforcement we can able to provide for a tension zone. Actually depends upon the load and soil carry capacity. So how the load will be transferred? So all the load going to transfer for the wall. Again, this wall load should be uniform. This wall going to spread into be a footing. That is a wall footing. Again, the footing is going to transfer into be a column. Again, one more pressure. So downward pressure for the vertical load and upward pressure for the tail load. The both should be equal and should be stable for the structure. So stable structure with no settlement or failure should not occur in the footing, that's safe of the wall. What is the practical insight of this footing? The wall footing acts as like a strip slab under the uniform loading condition. So we need to ensure stability of the wall and by the safe load transfer to the soil. So we need to provide the proper width and the reinforcement. It's preventing for the bending and it be a shear failure. So uniform pressure to be avoids to be excessive settlement. Then we need to see the second type, isolated footing, where we can use already discussed isolated footing using wherever having a single column, we can use for the isolated footing. So they're having a different type of the size, is the length and breadth is maybe a rectangular or is maybe a square also possible. Okay, so we need to provide properly for thickness of the that footings. So we can able to use commonly used when the soil is uniform and the safe bearing capacity is adequate and less, then we can able to use for the isolated pad footing. And second type is isolated sloped footing, where soil is near the has having a low bearing capacity and load is very high. We can go for the sloped footings. What is the advantage? Economical in the concrete. While seeing the pad footing, the consumption of the concrete is high, but here the slope footing, the economical in the concrete will be very low. So there also rectangular footing, where will be as a plan. If your load is acting on the sea, then automatically till the pressure side uniform pressure distribution will be occur. So it's based on the length and breadth and the load and the soil bearing capacity. So where we need to provide the reinforcement is the bottom and both the direction, main reinforcement as well as the distribution reinforcement. So like a slope fitting also having a two type of thickness will be there, T1 and T2. So the total thickness we can able to measure up to ground level will be a small thickness. There if load is acting on the CG, then the soil pressure is the uniform. If the load acting on this from far away of the CG, eccentricity will be active, that is non-uniform pressure will be on the bottom of the soil. So here the thickness of the at the top the T1 will be a small portion of the area. So the thickness of the bottom T2 should be a larger. So based on the that one, we can able to design the slope proof footing. So what's the key point we understand for this slope proof footing? Isolated pad footing the support a single column. The flat footing used for a good uniform soil pressure. Slope footing is used on a weak soil or heavy loads. Footing spread the column and over the large area and reduce the pressure on the soil. So we need to provide the reinforcement where the tension will be occur. For this type of the footing, the tension will occur the bottom faces. Then we need to provide the bottom face reinforcement. So this is a load mechanism, load transfer to the mechanism. All the column load from the structure, that's the roof slab and beam and slab and everything load is transferred to the column. Then it be transferred to the footing. Load is spread over the larger area. Then all the load is be transferred to the soil. So within the save the minimum bearing capacity. So isolated footing is like a base of for the column. It distribute the load on the soil so that the structure remains safe and stable. So axial loaded, the rectangular footing. So the concept is load is acting on the center, not in the face CG. The soil pressure is uniform. Then we go for the uniform side isolated rectangular footing. The behavior is isolated footing is the footing bends in the upward direction, that will be a conveyor direction. So it will be tension develops at bottom and compression develops it will be at top of the footings. So bending causes tension in the bottom. So steel is provided in the bottom only because where the tension will be occur. So if you see the reinforcement details in the plan section, main bar will be along the length direction. The distribution bars is along the for the width directions. Then we need to provide the proper thickness of the footing slab. So steel is provided at the bottom in the both direction to resist the tension. So if you see the critical section while calculating the reinforcement details, maximum bending at the face of the column and shear will be occur for the near the support section. So critical section for the bending at the face of the column and critical section for shear at the distance of D from the edges, and also apart from that we need to consider the uniform side. So here two type of the failure is will be there, that is called the shear types. One is a one-way shear and second one is a two-way shear. Other name is called for the punching shear. The punching shear is very important because sudden impact load we are going to produce into the soil, then it will be safe to reasons for a load condition. So failure surface is vertical in the one direction, that is called one-way shear. The column is tried to push through to the footing. Footing, then we can say for the punching shear or the two-way shear failure. So punching shear is practically critical perimeter at the distance of d by 2. D by 2 distance only the critical or punching shear going to be failure from the column faces. Like a brushing the finger into the soil, soft soil, that is going to be happen. So punching shear is the most critical check for the footing design. If not safe, the sudden punching failure will be happen, that we need to consider properly. So concept of this footing is the load act on the center. In case soil pressure will be uniform. The behavior of the footing is a bend upward direction. So tension will be developed in the bottom and compression will develop on the top. So reinforcement provide the bottom steel both direction along the longitudinal direction and the lateral direction. So critical section bending at the column faces and shear at the near the support. So shear type, we having two type of the shear. One is the one-way shear, that is a vertical shear, and a punching shear failure are based on the punching shear of the column. So key line, the punching shear it will be a most critical checking for the footing design. So while designing the design of the footing to resist the bending in one-way shear, especially for the punching shear for the safety and the stability of the structure. So, so last we see the load is acting on the CG. Now for eccentrically loaded at the PF footing, so load does not passes to the center, is far away from the CG. That so pressure is not a uniform. The pressure should be different. Where having a E, then having a load high, then pressure should be very high. So behavior, one side having a high pressure, another high side having a low pressure. So this is a soil pressure distribution diagram. So where having a E, they are having a high pressure. Then other side should be a low pressure. If ascending should be high, automatically the settlement will be happen initially. Okay, the tension developed in the soil will be an outer load. So soil take a only for compression. Never tension, automatically the failure will happen over the foundations. So while for designing the ascending load or sitting, we need to consider the design approaches. So what we need to do, we need to increase the footing size in case of the load is acting on from the CG. So large base reduce the maximum of the soil pressure, shift centroid of the column. So place the footing such that resultant load passes through within the middle third rule of the paces. So and also further ensure the pressure is always be compressive. The maximum pressure at it must be always less than or equal to be a 0. Now that is a B by 6. So condition for the no tension for any edges, E is less than or equal to B by 6 of the column. So load is near the boundary or unequal loading we can able to use for this type of the footing. So soil can take only for compression, never taken for the tension, but in case of the eccentric loaded footing. So design eccentric footing keep the pressure and compressive on the entire basis. What is the summary we understand based on this one? Concept is load does not pass to the center. That is the non-uniform soil pressure will be occur on the bottom of the page. Then behavior is one side will be high pressure, the other side will be a low pressure will happen. So dangerous be condition, high eccentricity and tension will be soil and be not allowed. While designing approach, increasing the footing size, the shift the centroid, ensure the pressure will be a compression. While see the practical is example for this one column near the boundary or unequal loading or ascend the footing we can able to prefer. So soil can be only compression, then never can be taken. So prevent the settlement, so cracking and a failure of the structure we need to encounter. And next is be isolated via the sloped footing. Already we discussed where we need to use the isolated footing. So when you're using the isolated sloped footing, then we reduce the material, especially for the concrete, and also be more economical. This type of the footing, the behavior is thickness is decrease towards the edges. Okay, while coming to the middle, the thickness is high. When you go into the edges, thickness is very less. The same structural action as a flat slab going to be action on bottom also be uniform soil pressure also will be act. The structural action that is called a bending, shear and punching is the same as a flat isolated footing. Only thickness will be varies. Okay. If you see the thickness of the variation, in top having a less thickness and top having a high thickness, and while coming to the bottom having a less thickness. Okay, generally the thickness will be 0.25 to 0.5 C thickness of C. So value which be depends upon the span and the varied loading condition. Okay. So practical insight to provide the more concrete where the stress will be high near to the B column. So we need to thickness will be reduced towards the edges to save the material. Slope footing is a transfer load soil will be uniformly. When you be saying the economic, the efficient design for isolated footings. Okay, so we need to use the to material and causes and thickness of the decrease and towards the edges. Same structural action as like a flat footing also. So providing the more concrete near to the column where the stress will be high. Ensure the uniform soil pressure. So here a flat rectangular footing and slope rectangular footing. The uniform soil pressure will be occur. Only major difference is thicknesses. Now the middle having a more thickness while coming to the edges, the thickness is very low. So automatically we reduce the material that is a more economical. So for the providing for the more concrete, where the stress is the more high near to the column and reduce it towards edges to save the material. Provide the more concrete where the stress is high near the column. That we need to understand clearly when you're choosing for the sloped footing. Now we are going to discuss about the combined rectangular footing. Where we use a combined rectangular footing, column is a very near to close, one column near the boundary, then isolated footing is not possible, then we can go for the combined footing. We are having two type of the combined footing will be the one set trapezoid as well as the rectangular combined footing. Where near the isolated footing not possible or maybe chances are overlap. So that condition better choice is be going for the combined footing. So two columns share the one footing. Then single footing it supposed both columns we can go for the combined footing. So resistance load must pass through the centroid of the footing. That means between the two columns the load should be act for centroid of the footing. We ensure that the column is to be structure will be safe. Ensure the uniform pressure. There is no tension in the soil. So behavior as usual like this, like a beam resting on this side, having a two loads will be there. The soil reacts as the upward direction. The column loads will be acting in the downward direction. So distribution, soil reacts acts in the upward direction. The column loads react in the downward directions. Okay. So where having a load is be high, where they're having a more pressure, where load is very less, then or also the pressure also be very less direction. By seeing the reinforcement details, the provide is similar to the beam reinforcement, bottom steel for the tension, reinforcement bottom view. So main bar as well as the distribution also we need to provide the both direction. So here the tension is developed at the bottom. So to steel also providing the bottom of the section. Here like a stapled footing or sloped footing, the combined footing also having a two type of the shear failure. One is a bending failure. Bending it will be occur in the critical section between the column. That means face of the column. The shear will be near the face of the column at the distances from the face of the column. So bending between the column and shear will be near the column we need to design. So combined footing is a balanced load where space will be limited. So it will be avoid for a heavy eccentricity if reacting that we need to avoid on a tension to the side. To ensure the safety and economical design when isolated footing is not possible, we can go for the combined footing. When a combined footing is balanced load and a space will be having a limit. So what we understand when you design the combined footing, when the column are near the close or near the boundary, isolated footing is not possible that we can go for the combined footing. So what is the concept? Key concept, the two columns are sharing the one footing. The key requirement resultant load must pass through the centroid of the footing. We need to ensure the uniform soil pressure in the below of the footing. So as you say, beam behavior is actually like a beam resting on this side. So load distribution also same. The soil reaction is the upward and column loads will be acting on the downward direction. So reinforcement, how we did for the beam reinforcement, same like that. Where is the tension be acting, there we need to provide the reinforcement both the bottom as well as the tension side. So when talking about the critical section, the bending between the two columns will be happen, and near the column the shear will be happen. So combined footing is a balanced load and the spread will be limited. So it's a combined footing balanced load and the spaces be limited. Now, keep the resultant within the centroid. That means uniform pressure, the safe design for the rectangular combined footing. So important check all the type of the footing, isolated footing, that is a paired footing, sloped footing, and the combined footing for the condition. The first one is self-bearing capacities of soil in a paired footing. The maximum soil pressure less than or equal to allowable bearing capacity. So we can say for the ensure the soil can be safety carry the load the safe design for the isolated pad footing. When see the bending moment, bending moment, checking the bending moment at the critical section. So MU less than called for the MU allowable bending capacity, ensure fitting the enough strength for the bending action. Then one-way shear. When see the one-way shear distance to the D from the face of the column, the VU is a less than or equal to VC for the one-way shear. That means to prevent the shear failure by sliding the one direction. Punching shear or the two-way shear. Check the around the critical perimeter D by 2 distant from the face of the column. That means VU less than or equal to VC. That is a punching shear. That means preventing the punching failure around the face of the column. The settlement control. Total settlement should be within the permissible limit. Ensure safety and serviceability performance for the structure. So what is a failure in the common structure observation? Very useful for the learners, the students. Footing is a crack if the poor reinforcement or uneven the soil, that is the settlement of the soil. The cracks indicates that poor design or execution will be occur. So if a tilting failure, it occurs due to the eccentric loading or uneven loading condition. So leads to the stress concentration and failure. So failure is often due to the punching shear, common columns within the heavier loaders. Okay. So also we need to remember that soil can able to take only for compression, never be a tension. So always try to keep pressures in the uniform. If ununiform, is not be allowing the pressure. So wall footing, the uniform load will be there is isolated footing for a single column purpose. We can able to use eccentricity footing when a load is not in a center or uneven pressure. You can go for eccentric loading. And a sloped footing, economical design and thickness is reduced towards the edges. Material consumption is very low. The combined footing, where two columns, when the isolated footing is not possible near to the boundary, we can go for the combined footing also. So final line, what is that? Footing and design ensure the safe transfer load to the soil without causing the shear failure or excessive of the settlement. Okay. Okay. So here's a module outcome. As a student, now you learned identify the different type of the footings. Now you can go to the field. If you see the any type of the footing, you can able to understand that you can able to identify the different type of the footings, whether it be isolated footings or combined footing or strap footing or raft footing. You can able to be identified. Now you can able to design the different type of the footing, either it be a wall footing or isolated slope footing or pad footing, whatever footing, using the design concept and as per code book, we can able to design the footings. Then we can able to analyze the axial eccentrical loading, the behavior of the footing under the axis as well as the eccentrical loading. We can able to design. Then you can able to check the pressure distribution and bearing capacity and the safety also. Now you can able to evaluate the slope footing behavior on the sloping ground for evaluation of the pressure variation and stability and the safety point of view. Now you can able to design the combined footing for the two columns and design the footing for two columns in isolated overlap. Now you can able to understand that the strong foundation for the safe structure, the proper design and ensure the stability of the structure. We can able to follow the IS code for reliable of the result for the making the good structure. So good design today and structure is safe is tomorrow. So foundation is very important for the structures. So thank you. So now if you see overall what is the course outcomes for each and every module. So module one, it's a course outcome is know the various design and concept and design the RC rectangular beams by the working stress and the limit state methods. And CO2, to understand the design of the flange beam and design for the shear and the torsion and the bond and anchorage of the length. Module 3 outcome is design the RC slab and the staircases and draw the reinforcement D-lines. Module 4 outcome is design a short column, axial, uniaxial, and biaxial loading system. And CO5 is design the wall footing and isolated and combine the rectangular footing. These are the 5 unique outcome for all these the entire courses. In other column, we shown the different Bruce taxonomy from the K1 to the K5 level. Level will be there. So this is the program outcome described by National Board of the Accreditation from the PO1 to the PO12, starting from the engineering knowledge, problem analysis, design and development of the solution, conducting the investigation for the complex problems, modern tool usage, the engineering and society, environmental and sustainability, ethics, individual and teamwork, communication, project management and finance, finally, and lifelong learning. So it's a department specific outcome we framed for the three types. The first PSO one is apply the mathematical and problem solving skills to identify and provide the solution for the solving complex engineering problem. And PSO2 apply the structural and construction knowledge to design safe and economical and sustainable civil engineering solution. And PSO3 enable the students to use their technical expert in the latest technology and apply their knowledge and continuously civil engineering to be the excellent their careers. So this is the POs and the POs the outcome. So based on that, we are framing the for the program mapping a system. Okay, so one is called for low, and two is for medium, and three is high. If you can, there should be no correlation based on that. But we are mapping the CO2 mapping for this particular code, that is a design of reinforced concrete elements. So as per we can able to use again this two book for a design of reinforced concrete structure and reinforced concrete design for the unification president and Krishna Raju for this entire chapters. So thank you all for your patient listening, listening of the all the entire courses from the unit 1 to the unit 5. Thank you very much. So very soon we are going to see the for next new courses. Thank you all.